Okay, hi Zach. This is lesson number 36 for you, and it's going to start on page 146 if you want to follow along. And the title of this lesson, it's definitely kind of a mouthful. It's the distributive property of rational expressions that contain positive exponents and also minus signs and negative exponents. So I know that might seem like this guy from Oh Brother, Where Art Thou? Where Art Thou? That don't make no sense. Anyway, it will. It will make sense after I explain it. So, the first thing that we're going to do as part of this lesson is a really quick review of multiplying fractions. So, you remember that if you have sort of a fraction that looks like this, let me just erase this for now so we can go over it. If you have a problem that looks like this, where you're multiplying 2/3 as a fraction times 5/7 as a fraction, that is super easy because all you do is multiply the numerators. So 2 times 5 is equal to 10. And then you multiply the denominators. 3 times 7 is 21. And so that's your answer, is going to be 10/21. So you know how to do that already. That's just a really quick review. I know that you're saying this right now. I know you know. But the reason that they pointed out is because sometimes when you change a little bit of something, like throw in some variables in there, then you're like, wait a minute, what the heck, what do I do with this? And what I want you to realize is that when there are variables, you are going to do the exact same thing. So it's going to be nothing new here. So let's take a look at this. These are two fractions that are multiplied by each other. Okay, so first we have mx over 4y. And we're going to multiply that by ax over 2y. So even though it seems like it's something new, we're not going to do anything new. What we're going to do is we're going to multiply this numerator times this numerator. So mx times ax is just going to be, well, there's an a, so we'll put that there. There's an m, we'll put that there. And then there's two x's, so it's going to be x squared. So x times x, which is x squared, right? Not 2x, don't do that. It's x times x, and that means x squared. And then we do the same thing on the bottom. So we're going to multiply this denominator by this denominator. So 4y times 2y. So 4 times 2 is 8, and then y times y is y squared. So this is going to be the answer right here, amx squared over 8y squared. So the next step is to realize that the distributive property of real numbers, see here's, I can do this all day. You're probably feeling like that, right? The distributive property also works with fractions. So that's going to be the next step. And just one other thing to point out, rational expressions, remember at the very beginning, the title said the distributive property of rational expressions. Well, rational expressions just means that it has a fraction in it. And so the way I remember that, just look at this word. It says ratio. So a ratio is kind of like a fraction, right? So a rational expression is an expression that has a fraction in it. So that's all it means. So when we do distributive property of rational expressions, like it said in the title, which was kind of a mouthful, and you're kind of like, what the heck am I doing? All you're doing is you're doing the distributive property, but now they're adding a little more complexity by putting fractions into the equations, okay? So that's all we're going to do. So here is an example, and the example is x times y, and you could put like parentheses here if you wanted to, but you know, it's not necessary because that's just the expression outside of the parentheses. And then you have an expression inside the parentheses that is separated by this subtraction sign. So as you know, with the distributive property, we're going to do two multiplications. We're going to multiply this by this, okay? And then we're going to multiply this by this, okay? So two multiplication problems, and otherwise it's exactly the same as everything else, okay? So I'm just going to move this to the side a little bit so I have a little bit more room, make it a little smaller here maybe. Okay, so two multiplication problems, and we're going to start with this, we're going to start with, well, let me just do this. We're going to start with this times this, okay? So x over y times a over y. What are we going to end up with? We're going to end up with x times a on the top and y squared on the bottom, okay? And then I'm just going to put this minus sign because of this minus sign here, okay? And then we're going to do that second multiplication problem, which is this times this. Okay, so it's going to be on the top, xb, and on the bottom, this is just kind of like b over 1. So if you think about it that way, it's a little easier. It's just going to be y times 1, which is just y. And look what I did. I didn't separate that enough over here. I just used my minus sign, which was silly. Anyway, there it is. So that is going to be the answer there. All right, so that's what we're going to do. And let's do some examples, and you will figure it out as we go. So example 36.1, which is halfway down the page on page 146, it says, use the distributive property to expand this expression. So once again, I feel like I didn't quite give myself enough room, so I am going to move this to the side, maybe make it a little smaller there, because you can see it in your book. It's going to be the exact same thing. So the first thing I'm going to do is multiply this times this, okay? So on the top, I'm going to have x to the 4th, because it's x squared times x squared. And remember that when we multiply something with exponents, we add the exponents. On the bottom is going to be y to the 3rd, because we have a 2 right here as an exponent. And then this y is just basically has an exponent of 1, because there is no exponent there. Okay, now we're going to subtract, put a subtraction sign because of that subtraction sign in the middle, and we're going to do the second multiplication problem, which is this times this. Okay, so x squared times 3y to the 3. So I'll just do 3 first because that's like the coefficient, and then I'll do x squared, and then I'll put the y cubed. Okay, and then on the bottom of that, I'm going to put y squared and m, okay? And then basically that's it. That's all they expect us to do. Just get it to this point, and then we're good. So it's just we're just using the distributive property just like we had before, except we're doing it with fractions or rational expressions. So you're probably like, okay, I got this. Give me another one. Yes, here we go with another one. We're going to do example 36.2. Keep paying attention even if you think you know it, because as you know, these examples get a little bit more complex and they're going to throw in some tricky things here. Okay, so here it says use the distributive property to expand this expression. Alrighty, so we're going to do, first we're going to multiply. And then, if we can, we're going to simplify that whole thing. So first, we're going to multiply. So 2 multiplication problems. First, this times this. So I'm going to write it underneath this time. So it's going to be, first I'm going to do the numerator. MAXP, because nothing is doubled or nothing is multiplied by itself. So it's just all of those things. And then on the bottom, it's going to be ZMK. And then I'm going to put a minus sign, and then I'm going to do the second part of the equation, which is multiply this by this. And I'm going to think of this expression over here as a fraction over 1, okay? So when I multiply the numerators, this time I'm going to do 2m, and how many m's are there? Well, there's an m to the 4th over here on the right, and over here, there's just a single m to the 1. And so if I add those exponents, it's going to be 4 plus 1, which is 5. And then I'm going to do the p to the 4th. So don't forget about that. And then on the bottom, you've got just the 1 right here, and you've got a z right here. So on the bottom, it's just going to be a z. Okay, now we can simplify this a little bit because there is something that cancels out, right? So if we cancel out, let's use that color. So there's an m here and an m here. So that can be canceled out. And that's basically it. So if I simplify that after canceling that out, I just have AXP over ZK minus 2m to the fifth p to the fourth over z. I actually like algebra. I think this is kind of fun and satisfying. So hopefully it's not too painful for you. If maybe you might be a nerd like me and like it, but I think it's actually kind of fun. Hopefully it's not getting too annoying for you yet. That's why I put this little girl, because she is being very annoying. I hope that I'm not being very annoying. I probably am, but that's okay. That's my job. So we're going to move on to example 36.3, and it says use the distributive property to expand all of this. So they are making it more complex, just like I promised, because check this out. There's one expression, two expressions, three expressions within the parentheses there. So we're going to have to do three separate multiplication problems. So we better get going. We're going to first multiply this by this, okay? So if we do that, on the top, we're going to have a squared, b squared, and x, because, right, there's an a here and an a here, so that gets squared. There's a b here and a b here, so that gets squared, and then we just bring down that x. What about on the bottom? We have a c squared and a c1 here, basically, right? So it's going to be over c cubed because we add those exponents, all right? Then I'm going to put a plus sign because of this plus sign right here. All right, let's get ready to do the next multiplication problem, which is this times this middle one. And we're going to think of that as an expression over 1, because that makes it easier to multiply. Now, on the top, I'm going to have a 2. I'm going to have an a, only one a because of this guy right here. How many b's? Well, there's a b here and there's a b here, so it's going to be b squared. I said b a lot of times there. And then don't forget about this x right here, so we're going to bring that x down and add that to the top of the expression. And on the bottom is c squared just times 1, so I'm just going to put c squared. Now, I'm going to put a minus sign because of this minus sign right here, and then we are going to do our last multiplication problem, which is this first expression times this last expression. Okay, so I'm going to circle those just to make it clear what I'm multiplying right now. And on the top, I'm going to bring down the 4 and the a and the b. On the bottom, we have a c squared and another c squared, so that's going to end up being c to the 4th. Now I'm going to look across the whole expression and see if there's anything that I can simplify. And it turns out that I can't, because there's only c's on the bottom and there's no c's on top, so nothing is going to get canceled out. Therefore, this is my final answer. Bam! All right, see? Cool. Okay, let's move on to 36b, which is another new concept. And 36b goes over minus signs and negative exponents. So we've already talked about that before. This is why I put Eeyore here, because he's like the most negative person I know other than Danny. Don't tell him I said that. Okay, so he's saying, I knew it was too good to be true. Yeah, you thought you were done, right? But no, not yet. Here we go. Remember that a minus sign in front of like a number or an expression, like maybe in front of a negative 3x or something like that, it means it's opposite day. It means it's the opposite of the expression. So that's because if you have a negative of a negative 3, it's the opposite of negative 3, and it ends up being positive 3, right? So just remember that it's the opposite of an expression if there's a minus sign. However, if you have a negative exponent, like 3x to the minus 2, that means something totally different. And do you remember what that means? It basically means the inverse of the expression, which means, well, let's see, let me do this. It would mean that you move the x from the numerator to the denominator, and then you can change the sign like that. And so this is no longer on the top, it would be on the bottom. So that's what it means when you have a negative exponent. So it's something that's totally different. So because that's confusing, we are going to go over a bunch of examples. So let's start with an easy one. 4 squared. What does that mean? Well, it just means 4 times 4, which is 16. Okay, easy peasy. We know that one, right? Okay, I'm going to move on to b. So b is 4 raised to the negative 2 for an exponent. Okay, so this is probably a little bit of a review, but I just went over how to do this. So remember that when you have a negative exponent, what you're actually going to do is move this expression because, how do I say this? This exponent applies to this expression, which is immediately in front of it, right? Okay, so what you do is you move that expression from the numerator to the denominator and then change the sign of the exponent. And then you're left with just a 1 on top. So it's 1 over 4 squared, which is the same as 1 over 16. Okay, so I think that you remember how to do that. If you don't, let me know. Write some comments in your homework. So those are pretty straightforward. Now, when we get to problem C, it's a little bit more tricky because you've got this negative sign here in front of the 4. And the way that I remember it is that if you look at this exponent of 2, it only applies to what's immediately in front of it. So it only applies to the 4. It does not apply to the negative sign. In other words, when you're multiplying 4 times 4, that's what it would be, 4 squared. It's not negative 4 times negative 4 because the negative is not right in front of the exponent. The negative is not squared. So that's kind of how I remember it, but you might have your own trick. In the book, what it says to do for a trick is because that negative sign is not protected by parentheses, it says to just pretend it's not there by putting a finger over it. So I'm going to try that and let's see if that helps you. So let's put a finger over that negative sign. Look, that kind of looks like a nail. Okay, there you go. There's a finger. We're just going to pretend it's not there. And then we're going to do the problem as if it's not there. So 4 squared is the same as 4 times 4, which is 4 times 4 is 16, right? And then once you're done with the problem and you figure out what it is, then you take your finger off that negative sign and realize that what you want is the opposite of that. So we're going to bring this negative sign over here and do the opposite of 16, which is negative 16, and then negative 16 is your final answer. So I don't know if that helps you sort of remember what to do with those minus signs, because the minus sign is not enclosed in parentheses, it's not protected, so you can cover it with a fingertip. Okay, so that's one way to do it. Anyway, the answer is negative 16. Let's go on to D. Now, in this case, the negative sign here is protected by these parentheses, so we cannot cover it with a fingertip. And in fact, what we're going to do is we're going to square negative 4 times negative 4. If you do it my way is when I look at the exponent, I think, well, the exponent applies to what's immediately in front of it. And what's immediately in front of it is actually, the parentheses. So anything inside the parentheses is getting squared. Everything inside the parentheses is getting squared. So that's kind of how I think of it, or you can do the fingertip trick. So whatever works for you. But anyway, it's negative 4 times negative 4, and as you know, when you multiply two negatives, you end up getting a positive. So the answer is positive 16, and I don't know why I put parentheses there because you definitely don't need it. Okay. So I think you understand that. Let's go on to the next one. The next one is E. Now this one's a little trickier, and this one you're going to have to use one of those tricks, right? I'm going to move the negative sign a little bit off to the side so that it's not too confusing. if you use my trick, then what you'll realize is that this exponent applies only to the 4. It does not apply to that negative sign. Okay, so what I would do is just imagine it only with the 4. So it's 1 over 4 squared. And then I bring that negative sign and put it in front of that whole thing. And it really doesn't matter if I put it over the top or the bottom. The answer is going to be negative 1 over 16. Okay. The way that the book says to do it, and let me do it that way as well, just so that it's not confusing. It says, once again, put your finger, this time we're going to have a blue finger. We're going to put our finger over that and just pretend it's not there. And then kind of do what I did, which is 1 over 4 squared, which is 1 over 16. And then take your finger off that negative and realize, I want the opposite of that. So the opposite of 1 over 16 is negative 1 over 16. And that is going to be my final answer. Okay, so whichever way works for you, try doing it that way. Now, we're going to move on to F. F is another tricky one. This is one that a lot of your friends are going to miss. When they see this on an ACT test, they're going to get it wrong for sure. I'm not going to get it wrong because I'm going to think of my rule, which is the exponent applies to the parentheses. And so therefore, I must square or do whatever, quadruple, whatever, to anything inside the parentheses. So when I change this from the numerator to the denominator, I'm going to do this. 1 over negative 4 squared. So the sign that changes is the sign on the exponent when I move it from the numerator to the denominator. And then I realize that this is going to be 1 over negative 4 times negative 4, which is 1 over a positive 16. So we just did that before. Okay, so now I'm not going to get it wrong because I've got my way of doing it on an ACT test. Your friends are not going to do it that way, so they're going to get it wrong. But you could do it the way the book says. And the way that the book says is put your fingertip, actually no, it says because this negative sign is protected by these parentheses, you cannot put your fingertip over that negative sign. You can only put your fingertip on negative signs when they're outside of the parentheses. So therefore, they basically did it the same way I did, which is 1 over negative 4 squared, and then they got the same answer, which is 1 over a positive 16. Okay, basically, that's a wrap. Get it? That's all the examples. So now you get to go ahead and do your practice problems. That starts on page 148 and goes all the way to 149. Enjoy your homework for today. Have fun with it. Bye.